Hello everyone, welcome to you all. So we are continuing with the same topic, that is half wave controlled rectifier. In the previous two videos that I have uploaded, we have seen that the basic working principle of single phase half wave controlled rectifier, then why it is called a controlled rectifier one, and we have done the calculations, important calculations starting from V naught average, that is the average output that we are getting, average value of current that we are getting, including RMS values and so on. So today we will try to continue with the same topic. Instead of taking only resistive load, that is R load, we have taken RL load. So today we will try to understand the working principle of half wave control rectifier when the load is inductive in nature. So already I have drawn the diagram here. You can find, instead of having a single resistive load, we have connected an inductor in series with the resistance, so that the load becomes inductive in nature. So today we'll try to understand when the load has a different characteristics, that is the inductor, then how the circuit behaves. So let's try to understand that one. So we will explain the topic with the help of diagram that we have drawn in the previous videos. So once again, you know, Vs is the supply voltage or the source voltage. We have taken that is as a sinusoidal one. So if I represent Vs with the diagram, then we know it looks like this one. So assume this is the waveform of the Vs. This is the waveform of Vs. Because for our discussion we have taken Vs as a sinusoidal source. So this is definitely Vs, and here we have taken in this direction, that is omega t. Now in the positive half cycle, what happens during positive half cycle? I am writing here, during positive half cycle, what will happen? The thyristor is forward bias. But we know, as this is a thyristor device, so even if it is forward bias, the thyristor cannot conduct. So if we want to turn on the device, then we need to provide gate current. So to turn it on, along with the forward bias, we need to provide gate pulse. So the gate pulse will produce a gate current. So that is the Ig we have taken as the gate current. So assume this is the angle at which we have applied the gate pulse. Similarly, in the negative half cycle, it is the reverse bias. So no need to provide the gate pulse here, because even if we are providing gate pulse here, the thyristor will not turn on. In the positive half cycle, 1 second I need to provide gate pulse. So might be my diagram is not so good, but hopefully it is enough to understand the topic. So here you can find at this angle, what is the angle? We normally take this angle, we represent this angle as alpha. So at the alpha angle, we have applied gate pulse. So when you're talking about angle, hopefully you can understand the different values of the angle that you want to describe here. So at the beginning, the angle is 0. This is the pi, this point is pi, this is 2 pi, this is 3 pi. So here the actual value is 2 pi plus alpha. So in this way it goes on. Now as we have applied gate pulse in the forward bias condition, then what will happen? The thyristor will turn on. So that means in this region the thyristor is on. So similarly here thyristor is on. In the reverse bias condition, we know the thyristor is off. Now when thyristor is on, what does it mean? This becomes a closed path. The thyristor becomes a closed path so that the current can flow through the load. Now here the nature of the load is inductive one. So due to which we need to understand what should be the relation between V0 and I0. What is V0? V0 is the output voltage that we can get across the load, and I0 is the amount of current flowing through the load. Now here we want to understand the relation between V0 and I0, and we will do that with respect to the diagram. So this is the position of gate pulse. This is the corresponding position of pi angle. Let me mark it. This is the position of angle 2 pi. This is the position of alpha. This is the end of 3 pi. So hopefully it is easy to understand. So start with V0. That is what I want to draw. Now output voltage will appear only when the thyristor is on. That means thyristor is conducting. So from 0 to alpha, thyristor is off. So no voltage will be available. So V0 will be 0. I am writing here. From 0 to alpha, thyristor is off. On কোথায় আছে? So from alpha to pi, the thyristor is on. Once again, from pi to 2 pi, we assume that the thyristor will be off, but we need to understand whether it will be off or not. That is something interesting that will happen here. Why? We will explain that one. So from 0 to alpha, we understand that this is as the off. Now as soon as we have applied gate pulse, thyristor gets turned on. So that means the Vs voltage is directly available as V0. So whatever output voltage we will get when thyristor is on is basically due to Vs, and it will try to follow the waveform of Vs. So from here Vs starts building and it will follow Vs. Why the waveform is like this one? Because it basically follows Vs. This one is on, that means it's a short circuit. So whatever value we have applied here will be reflected here as V0. So that is why it should look like this one. Similarly, here thyristor is reverse bias, so voltage should be 0. Okay. Now as soon as voltage develops, we need to understand the waveform of current also and try to find that one. So here we want to draw the current waveform, that is I0. Now we know from 0 to alpha in this region thyristor is off, so I0 is 0. At this position, this amount of voltage is applied across this load, that means across the inductor also, due to which certain amount of current will try to develop. That means due to the application of this voltage, certain amount of current will try to flow through the path which has inductor within it. And what is the nature of inductor? We know inductor opposes any change of current through it. I'm repeating it once again. The basic nature of inductor is that it always opposes, or it always does not allow the current which is flowing through it have a rapid change in the magnitude. It does not allow that one. If certain amount of current is flowing through the inductor, inductor will not allow to change its value rapidly. So what happens? From this point, current will try to build up gradually. So current will try to build up gradually in this way. And when it will reach its maximum value, it will reach the maximum value when the angle pi, when the angle is pi. That means here you can find the difference. Current attains the maximum value when V0 is 0 as well as Vs is also 0. Now after reaching pi, what will happen to the current? After reaching to pi, we know that the biasing becomes changed. So from forward bias, it goes into reverse bias condition. During that state, thyristor should be turned off. Thyristor should be turned off. But certain amount of current is already charged up the inductor. Here we are saying the term charged up, like that happens in case of capacitor. Remember why I am saying that one is that inductor and capacitor both are energy storing components. Both can store energy. So as soon as current increases through the inductor, we can understand in this way, the inductor gets charged up. And what is the direction of that particular charged up, and the polarity of the inductor is like that. Whenever current is flowing in this way, that is in the clockwise direction, then the polarity of the inductor becomes this one, plus minus. Now in the negative half cycle, what will happen? In the negative half cycle, we can understand that the polarity of this power source is like this one. This one becomes plus, this one becomes minus. That makes the thyristor into reverse bias condition. Now in this particular condition, what will happen? Inductor will try to discharge. Inductor will try to discharge. Now during negative half cycle, when inductor tries to discharge, then its polarity will be like that one. This is minus, this is plus. That means this inductor right now behaves as an energy source, means it has a polarity in this way. This is plus, this is minus. That means it will try to deliver current once again in the clockwise direction. Now you might be thinking that this is minus, this is plus, this is also plus, this is also minus. So what is the relation between them? Try to understand from this particular topic is that this positivity of the source gradually increases here. That means the positivity of the source in this point with respect to this point is less. Similarly, the value of positivity in this direction, suppose at this point, is higher than this point. That means I want to say, with respect to angle as well as with respect to time, Vs attains its amplitude. It gradually increases in value. But what happens in case of inductor? In this region, when the angle is pi, the value is maximum. That means that EMF that it has stored has the maximum value. So that means At the beginning of this negative half cycle, what we can say in this way, the circuit has two energy source, both have polarity like this one, minus plus, but this voltage source has the amplitude which is very much less with respect to the inductor, which already have attained its maximum value. So that means at the beginning of this negative half cycle, this inductor becomes the dominant source which works over the presence of this voltage source. And due to this particular fact, for certain amount of time, this inductor will try to discharge through this thyristor. That gives us certain amount of current here. After certain time, suppose this is another angle, maybe beta. After beta, what happens? The voltage source in the negative half cycle attains that value which is higher than the potential of this inductor. So that means Vs becomes dominant one. Then only the thyristor basically experiences reverse bias finally. So you should remember that from pi to beta in this region, from pi to beta in this region, though thyristor is in reverse bias condition due to Vs, but what happens due to the presence of inductor, as it attains its maximum EMF at the angle pi, so that happens from pi to beta in this region, the EMF of inductor becomes the dominant source with respect to the supply voltage, that is Vs. After that, what happens as time passes, Vs gradually increases and the EMF within the inductor gradually decreases. So at the angle beta, what happens? The EMF of inductor becomes lesser with respect to Vs. That implies finally the thyristor is reverse bias. That means thyristor is off. We can say in this way also, as the inductor gradually discharges through this thyristor, after certain time at the angle of beta, the current flowing through the thyristor reaches the value below its holding current. So finally, not holding current, should be latching current, below the value of latching current. That is why the thyristor gets turned off. So the important thing is that instead of here, the thyristor will finally stop in this region. So instead of turning off at pi angle, it will actually turn off at pi plus beta angle. That is the important thing. So that means from pi to beta, thyristor is still on. So when thyristor is on, we will get the output voltage, and we know the output voltage follows Vs. So finally we will get the waveform like this one. After that, thyristor is off, so you will not get any output voltage up to 2 pi. From 2 pi forward, half cycle begins, but as we have not applied gate pulse yet, the thyristor will not be activated or will not be turned on. So at the angle alpha, 2 pi plus alpha, we have applied gate signal. That means thyristor will turn on. So up to this angle, the thyristor will remain in off state. After that, thyristor is on, so it will directly follow Vs. So the output voltage resembles the value of Vs. So V0 follows Vs. Similarly, at this angle beta, we know the I naught current that is flowing through the load reaches zero value. After that, thyristor is off, so no need of flowing current here. When current will be available? As soon as thyristor becomes on. So when it gets on, at this position it gets on. So once again, gradually the output current will try to increase, and after that, if we continue, it will try to decrease. So in this way, we can found that two different waveform will be available for this particular half wave control rectifier when we have connected an inductor in series with the resistive load. That means when we have made the load as an inductive one, the waveform of output voltage and output current changes. Now the interesting fact is that we want to get half wave rectifier. That means we should have positive pulses, but in this region we can found that some negative pulses is there. So that means due to the presence of this L, we are getting certain amount of voltage in the negative half cycle also. So it is not a DC output. So this is not a DC output. So though it is a half wave rectifier, but we are not getting any kind of DC output. So that is not desired. So that means the circuit does not behave in the similar fashion when we have changed the nature of the load. So how to overcome this problem? The solution is that we have to connect a freewheeling diode or sometimes it is called as flyback diode. What is that? Further we need to know the circuit arrangement. So I am drawing here. So this is the change that we have to do here. By following this dotted line, we have to connect a diode here, flyback diode. So I have given that name is DF. So in this way, we have connected a diode in this way. This connection is called freewheeling diode. This diode is called freewheeling diode or flyback diode. Remember, this is not a type of diode. This kind of circuit arrangement itself is called freewheeling diode. What is the purpose of that one? Now we have to remove this negative pulse. That is the problem. For that we have taken this solution. What is that? After pi, what happens? Negative half cycle starts. Negative half cycle of Vs starts. Now at that condition, what is the polarity of L? Already I have said, L goes into discharge mode with the polarity like this one, plus and minus. And at this particular time, that means whenever we have just crossed the value of pi, the EMF inside the L, inside the inductor is maximum and its polarity is like this one. Now for this particular polarity, this diode becomes forward bias. Now when this diode is forward bias, we know diode can conduct. Then what will happen? The inductor will try to discharge through this path. And when diode is conducting, we know at that particular condition, the internal resistance of diode becomes very small. So instead of discharging through this path, the circuit will try to discharge through this path. So that means whatever potential or EMF it has gathered during the positive half cycle will be eliminated via this diode rapidly. The energy stored within this diode, within this inductor, will be vanished via discharging through this diode. So that is why this arrangement is called freewheeling diode or flyback diode. So that means within very small period of time, this particular voltage that is available in the negative half cycle will be vanished, will be discharged via this diode. So if we connect this diode in this way, what will happen? This negative half cycle, this particular portion of negative half cycle will be eliminated. Then only we will get the DC output. So remember, to get the DC output in case of half wave control rectifier, when the load is inductive in nature, we need to connect a diode in this way so that the energy that has been stored within the inductor in the positive half cycle can get discharged via this diode rapidly in the negative half cycle of Vs. So that is the function of this one. This is not any particular type of diode. Remember, Schottky diode or Zener diode, or even normal the general diode, that is IN007. So IN4007 probably. I cannot remember right now. So it can be Zener diode depending upon application. It can be Schottky diode depending upon the application. It can be general diode or the most popular one. So depending upon the application, we prefer sometimes Schottky diode, sometimes Zener diode, or sometimes the general one or the most popular one. Okay, so that is the waveform that we are getting for this particular circuit, and it is possible, obviously possible, to find out once again in the similar way that we have done in the previous video, that the average value of the output, average value of the current, so everything including the RMS values, everything we can calculate similarly that we have done in the previous class, in the previous video. So that is all for the half wave control rectifier. In the upcoming video I will try to understand the full wave control rectifier, and that will be followed by bridge control rectifier. Thanks for watching. Thank you.